2 for the See You Succeed final, which again is happening on the Wednesday we get back. And I'll send out more details about this pretty clearly so you know what to expect, but it'll all be online. I will send it out to you at the time when your class is scheduled. Okay, so I'm going to send out period 2's test to period 2, and period 4 during period 4. So, and you're going to log on to a Google Meet Live, and your camera's going to be on. I have to preserve the integrity of this test as much as I can. Yeah, Delaney, good job. Write your name in the chat so I can take attendance. But the idea is to take this test as honestly as we can, because it's going to be really easy anyway. I think we're going to do pretty well. And I just want to make sure that I take today to cover the last couple things that I haven't done. But so keep an eye out on Canvas. I've already actually posted the topics that are going to be on the final, which you already know from taking that initial survey at the beginning of this week. Was that this week? To see where you're at. I'm actually, I have a survey that I want you to take after we take our lesson, do our mini lessons today, with all the same questions. I want to see how your feelings have shifted after this week. So on Canvas, you'll see a couple links there. One is to today's practice ones. You know, I'll do a couple examples up here, and then I send you to try one or two. So if you want to open that up, the questions will be on there that we'll work on. But also at the bottom of today's announcement, you see a survey, a follow-up survey. Real quick, I just want to see how you're feeling about these topics now that we've covered most of them. And now we've obviously learned everything that we need to, but some of them are, you know, chapter 2 kinds of things that maybe you're still not comfortable with yet. I just want to get a sense for what you feel good with and what you don't, so I can design a review that works. Obviously, everything is going to be on the review, so you know what to prepare for. But when we think about the Monday and Tuesday when we get back, I want to make sure that I'm ready to support you in the stuff that you're still struggling with. Cool. So that's my plan. But here we go. Let's do it. Let's do some stuff today that either we haven't talked about at all in this class, and really it was old stuff from a previous class, or stuff that we talked about way back in chapter 1 that a couple people said that they wanted to see again. So that's what we're going to do. I've got 3 things that I'd like to do today. Work through them pretty quickly because the ideas aren't very complicated. Okay, but stop me, ask questions if you have any. And let's do it. Cool. So the first topic is absolute value equations. Okay. How to solve equations that have an absolute value in them. Because one of these is going to come up for sure, and I want to make sure that you feel pretty good about it going into it. And then I have a pretty straightforward strategy on how to solve these. And I'm going to start really simple. So that you understand why I do what I do, okay? So call this one number 1, example number 1. Just the absolute value of x equals 5. Let's say something, okay? And what we want to try to figure out is what number can I put in for x so that the absolute value of that is 5, right? And that you might be able to just think about and say, okay, I know what absolute value does. I know it takes whatever number you give me and it makes it positive. Okay, good. So that's a positive number. So I know I have possibilities for answers. But what are those possibilities, right? Well, absolute value means distance from 0, right? So I'm trying to think about what numbers are 5 away from 0, either in the positive direction or the negative direction, right? What number can I put right here whose absolute value is 5? Well, 5 would definitely work, right? But also negative 5, right? The absolute value of 5 is 5 because absolute value just says whatever number you give me the positive version back, right? And absolute value of negative 5 would also work. And so what I can do, and this is how I usually start my work when I'm working through problems that look like this. I'll switch colors so you can see where the work starts. What I like to do to solve these equations is to kind of rewrite it without the absolute value, but considering both possibilities, both the positive version and the negative version. So here's what I do. On the left-hand side, I drop the absolute value and I just keep whatever is there, right? And you'll see that there's going to be more than just x. And the problem could be x plus 2 or 2x minus 5 or whatever. But I drop the absolute value, but I still remember that there's two possibilities. A positive version of 5 could work, and so could a negative version. So what I do when I drop the absolute value, I'm going to put a plus or minus in front of this number because those are the possibilities that could work, either a positive 5 or a negative. Okay. Now, that's fine, just like that, plus or minus 5. But you're going to see we're going to have a little bit more work to do. So what I like to do from here is kind of consider both options separately. The case where x is equal to positive 5 and the case where x is equal to negative 5. And if I had some more solving to do for whatever that variable is, then I would do that. In this case, we're just done right there, right? X equals 5 and x equals negative. Again, you could have stopped right back there because that's fine, but you'll see that these questions usually have a little bit more going on in the inside than just x, right? So something like, I don't know, like the square, absolute value of x plus 3 equals 5. I like 5. Okay. Like maybe that's the question where things start. And because the absolute value is already isolated on one side, I know I can kind of jump right in and start solving this. If there was like a 3 out here being multiplied or a plus 2 on the same side, we'd have to kind of isolate the absolute value before we could do anything. But you'll see that, just like these, the absolute value is on one side and just a single number on the other. And all I'm trying to do with a problem that looks like this is figure out what number could I put right here for x so that the absolute value of the whole thing would be 5. Okay? And so it's not just going to be 5 and negative 5 now, right? Because 5 plus 3 is 8, and the absolute value of 8 is 8. That wouldn't work. So what I want to think about is what number to put in for x that's going to make the whole thing, x plus 3, either equal to 5 or equal to negative 5. And so to show that thought process, I'm going to do the same thing I did over here. I'm going to drop the absolute value and just write down whatever's on that left side without it. But when I drop the absolute value on the left, I'm going to add a plus or minus on the right. Because if x plus 3 is equal to 5, then cool, the absolute value of that is 5. But if I can make x plus 3 equal to negative 5, then the absolute value of that will be 5, and I'm finding a good answer. So here's where I personally, I kind of just break it into 2 equations to solve separately. Because I'm going to get 2 different answers. One where x plus 3 is equal to 5, and the other where x plus 3 is equal to negative 5. So I don't change anything about the left side besides dropping the absolute value. I just make sure I consider the positive version of the right side and the negative version, and I'll solve them separately and see what I get. Subtract 3 over here, okay, I get x equals 2. Subtract 3 over here, I get negative 8. Right? They're not always going to have the exact same numbers, one positive, one negative, because you have a little bit of solving to do after. Right? And think about it, like 2 plus 3, perfect, 5, right? Absolute value of that is 5. Negative 8 plus 3, okay, that's negative 5. Ooh, the absolute value of negative 5, yeah, positive 5. So it works. Okay? And so whatever you've got on the inside, do it, right? Leave the inside as it is and solve however you would need to. So if there was a number out front, deal with that too. We'll do one more. The absolute value of 3x plus 2 is equal to, I like the, yes, I like, stick with the 5. Sure, let's stick with 5. I don't know why. I like it. Because I want things to work out nicely sometimes, but not nicely the other times too. We don't always have to get perfect, nice answers, right? It just might so happen that it works out the way that it does. But I know what my setup's going to be. I'm going to drop the absolute value on the left and add a plus or minus on the right, okay? And this is where I break it apart right away into 2 problems. 1 equal to 5 and 1 equal to negative 5. And and then I just solve it. And I see what I get. Subtract 2, divide by 3. Nice, that one worked out real well. Subtract 2 and divide by 3. Okay, negative 7/3. Fine. If that's what it is, and that's what it is, and that's okay. All right, whatever your answers are going to be. A lot of times we expect to get those two possibilities because it's equal to some positive number, right? If it was equal to 0, we'd only really get one answer. If it was equal to something negative, we'd have nothing, right? I can't make an absolute value equal to something negative. So, so that's kind of the basic setup. They're going to give us a problem. It's got an absolute value on one side and just a number on the other. Drop the absolute value, throw a plus or minus in front of that number on the right-hand side, solve them separately. Right, and so let me, in case you don't have it up on your screen, let me share with you the practice from today. It is on Canvas. It just says today's practice, and there's 2 of them. Right, there's a couple of absolute value equations. Try those 2. I will. I'm going to erase the board on this side. I know you can't see me. I'm erasing the board over here, and I will put up some solutions. Take probably like 1 minute to do it. Negative 7/3 again. That's cool. Okay, so there you go. A couple examples, and they're simple because it's simple. Question on the final. There's just one. There's basically just one of each of these. When you look at the topics, there's just one question on each of those, more or less. And because it kind of covers a pretty wide range, they like to keep them simple when you do that. So that's kind of nice. Okay. Questions about that? Good. Okay, organize it however you want. This is usually how I do it. And again, remember, this is just a multiple choice test. But if you do get the wrong answer and you didn't show any work, there's nothing I can do. So you want to make sure that as you're taking this test, you are kind of writing some things down and submitting that to me via Canvas. I'll put a assignment on there for the final. That's where I'll probably link the review once I write it. So you have a spot on Canvas where you can upload whatever scratch work you do, so I can try to find partial credit in case you get something. In general, though, I feel pretty confident that things are going to go pretty well. All good? Sweet. All right. Moving on then. Let me erase this board. I'll give you one last second to look at those. And we'll do the next one. Okay. Right, coming back over. Hello. Cool. All right. Next idea, solving equations that have radicals in them. And I say radicals, I could just kind of put it all as square roots. Excuse me. Because that's what's going to be on the final. It's just going to be a square root question, but it works whether it's a square root or a cube root or a fifth root or whatever. So I'm going to call it solving radical equations. Solving radical equations. But really the only one you have to worry about are ones that have square roots. Okay. And again, I'll start simple with just the square root of x equals 6. I was going to do 5, but I've done that. Square root of x equals 6. Now, as we think about questions like these, and we think about dealing with square roots and solving them, of course, squaring things is going to have to come into play. Right? And if it was a cube root, I'd have to cube stuff. If it was a 10th root, I'd have to raise things to the 10th power. But what I want to caution you against is thinking about questions that start with an x squared being exactly the same as questions that start with the square root. When you start with something like x squared, and we take the square root, that's when we would need the plus or minus in the problem. We'd have to introduce that ourselves, because when you take the square root, you want to consider both possibilities. Like the square root of 4, well, maybe it came from a 2, or it came from a -2 to get us to 4, right? This problem is already starting with the square root. And if there's no plus or minus right now, then we don't need to add one, because we don't know that this came from an x squared equals kind of problem. Maybe this is just looking at square roots and just square roots. Okay, so you don't have to worry at all about adding the plus or minus. Okay, we just have to solve it. And we would solve it just the way we would normally solve any equation, undo whatever's happening to x to get it by itself. And since x is stuck underneath the square root, we'll do the opposite of that, which is to square it. Okay, and whatever we do to the left, we'll just do to the right. Okay, but no plus or minus here. The square and the square root cancel each other out, so we're just left with x, and 6 squared is 36. We're done. Okay, pretty simple. Okay, just make sure you don't include a plus or minus when you don't really need one. Okay. Now, what's underneath the square root is obviously going to be more than just x. That would be almost too simple. But it could be, you know, x plus 3 is equal to 2. Let's say something like that. Square root of x plus 3 is equal to 2. And as long as the square root is by itself on one side, we can square it right away. If there was like a 3 being multiplied out here, or a plus 4 not under the square root but still on the left-hand side, you'd have to move stuff around to get the square root by itself. So you don't want to be squaring things that aren't squareable necessarily. But don't worry, it'll be isolated so that you can just jump right in. Whatever's on the left, we'll square it. Whatever's on the right, we'll square that as well. Okay. Square and the square root cancel each other out. So nothing about what's underneath that radical changes. Okay, that's not x squared plus 9 magically, or x plus 3 squared. Okay, the square and the square root kind of absorb one another, and we're just left with the radicand, right? Whatever is underneath that square root. And then I'll just square whatever the right side is. Right? 2 squared is 4. Now this one, I have one more step of solving to do to get that x by itself. So I'll subtract 3 on both sides, and there we go. There's x equals. There you go. It's not really much more complicated than that. There's not much more that I could do to make this complicated. The only thing that I could do is maybe add another number underneath being multiplied through x, or change the variable. The square root of 2t plus 7, right? Who cares what letter I decide to use underneath? X, Y, N, P, Q, T, R, whatever. Let's set that equal to like 3. Whatever it is, that's fine. Right? It doesn't matter what the variable is, just stick with it. If it's a t, then use t. If it's an m, use m. If it's an r, use r. If it's x, we'll stick with x. Okay? But because the square root's by itself on one side, I can just square both sides to undo that. Okay. And whatever is underneath the square root, when I do that, 2t plus 7 will stay. Right? Nothing changes about that. I just square the right side. 3 squared is 9. And then solve. Right? Subtract 7 on both sides. Divide by 2. And we'll just get that 1 real nice. That's it. I could make this much more complicated, but I don't need to. Right? I'm not going to do cube roots or fifth roots or anything like that. And I could put x's on both sides and make this a lot more complicated than it is. But this is the simple version that's going to be on the final, so I want to keep it relatively simple. Okay. Back to the practice, just so that you can try some without me to start. Let me reveal these questions to you. Solving some radical equations. There you go. Okay, so try those two. Make sure you're feeling okay with it. Again, I went with x here, but who cares what letter they use? And that's true for everything. Try those two, number 3 and number 4, and see how you do. Slide you over to this side where I'll work on too. Like that. Great. Take another minute if you need it. How are you? And number 4, 5 halves, 2.5 is fine. Just know that because it's multiple choice, only one of those versions is going to be on there. So you'll want to recognize either the decimal version of a fraction or the fraction version of that decimal. Okay? And so if you're working with decimals and you see a bunch of fractions in your answers, you can always type each fraction in your calculator. It'll spit out a decimal, and then you just find the one that matches. Or if you do have a graphing calculator and you type in the decimal, and you press the math button, and the very first option is arrow frac. It'll change it back to a fraction for you, so you can find the right answer. So if you don't recognize, 7/8 as 0.875, but 7/8 is the answer, or whatever it is, just be comfortable finding a way to bounce back and forth between the two, depending on what version they write down. Okay, remember, Cassidy was writing this final, not me. So, so there you go. Solving radical equations, pretty simple stuff. Just a little bit of algebra, and the right answer will be there. Okay. All right. One last thing, and that's it. Now, so we've covered everything. The one thing that I saw on the review survey that I sent out the first time is there something from chapter 1 that more people responded like 1s and 2s and even 3s than I expected. So I wanted to make sure that I talked about this in person. Even it's not a super complicated idea, but it's something that we did way back in chapter 1, and really haven't gone back to yet. So if this is something that you want to see again, then stick around for sure. But if it's something that you decide, oh, I know how to do that, I'm good, then I'm good, and you can head out. But either way, before you leave today, at the bottom of the announcement on today's date, there's a follow-up survey link with the same questions, the same rating scale. 1, I'm super confused. 5, I totally get it, and everything in between. For each of the topics that are on the final, please take a minute or two and just respond to that follow-up survey. So I know how you're feeling about certain topics. So I can look individually to see how I can help you do your best, but also how I can help the class do the best that we can as well. So stick around if you want, or not, it's up to you. What we're gonna do here with these last 10 minutes or so, we'll probably end early anyway, is to go back to chapter 1, which was all about functions, but specifically linear functions. Some people were still struggling with how to find the equation of a line parallel to or perpendicular to a given line through a given point. So I wanted to make sure that, because that's a bit of a process, some people wanted a refresher on that, so that's what I'm going to do, okay? If that is something you feel really good about, then you're good. Just go to the announcement, answer that survey for me, and I will send you on your way to Thanksgiving break. So happy Thanksgiving. And nothing you need to do for me over break. I will send out that review as soon as I write it. Could be tonight, tomorrow, who knows. I will send it out as soon as I can. I will do the solutions thereafter, and I will post those as well. But know this, okay? Monday we get back. We are live, okay? Got to be there for attendance purposes. Tuesday will be optional review live session with me. If you want to come, great. If not, I will let you know how you can be marked present for a day like that, okay? Things are changing a little bit with the remote attendance because now we're all basically just one big group again, one big virtual group, because social distancing is not necessary since we're remote all the way. So just keep an eye on Canvas. I'll post stuff there. And reach out if you have questions about what you need. Okay, so if you are headed out, answer that survey and have a great break. If you are sticking around, awesome. I'm going to work through a couple examples, and then there's some practice on today's practice with those that I will work through as well. Okay. The thing about finding these equations, finding equation of a line. When they give us a line and we want to be parallel to it or perpendicular to it, and I'm going to work through both. Now on the final, they're just going to ask for one or the other. But all of the answers are in slope-intercept form. They're all y equals mx plus b. Okay? So we don't really have an option as to what answer we want to get to, but we do have a choice as to how we get there. Okay? And so I just wanted to run through one example, at least, of looking at how to do it either way to get to that y equals 3x minus 4, or whatever that answer is going to be, y equals mx plus b. Okay? But what they're going to do is they're going to give us the equation of a kind of a beginning line that we want to either be parallel to or perpendicular to. So let's say like y equals 2x plus 5, something like that. Okay. And they say either be parallel to that or be perpendicular, and I'll do both. But they're also going to give us a point off of this line that we want our new line to go through. So let's say, I don't know, like 4 negative, I think I have 4 already, the other one. Let's do, sorry, gosh, 3, 2, 3, 5, sorry. Yeah, that works. Okay, 3, 5. And so they're going to ask us one of two things. I'm going to do both, but they could say find the line parallel to this one and go through that point. Okay. And so the work that kind of builds from here is to pull out all the important information that you need to get this question done. And the only thing that I care about when it comes to being parallel or perpendicular is the slope, right? So what's my slope that I'm dealing with? And what does that mean for the slope that I should be using to find my actual line, right? Well, the slope of this line is 2. Right, there it is, y equals mx plus b. So the slope of the line parallel to that, so just, it looks like 2 little l's, little subscript 2 little l's, is also 2, and that's the one that I want. I'm going to stick with that same number. Okay? And of course, I'm going to use this points to get there. Okay? Now, how you proceed from here is kind of up to you. Okay? And I want to show you both ways to do it. Okay? But I'm going to use this slope and that point. Maybe what you do is you start in slope-intercept form. Okay. Maybe you start dealing with y equals mx plus b for your line. Now, the thing about this that I do like is that that's the form that I know I want to end up with. So hey, why not start there, work through the problem, and make sure that my answer looks like that when I'm done. Yeah, that's a really good thing to start with. The thing about this one that I don't like as much is that you're starting with an equation, you're going to solve it, but that's not going to be the answer because we're solving for b. I know what m is. I got to figure out what b is to get there. So when you set this up and you say, okay, 5, there's y, equals 2 times 3 plus b, you are creating an equation that the answer is b equals, not y equals mx plus b. Which is fine. You just have to make sure that once you work through how to solve this problem, right, multiply the 2 and the 3 together, and then subtract 6 on both sides, and you get b to be -1. You're not done there. You're done here. Y equals 2x minus 1. That's your final answer. And that's great. Pretty simple setup. Plug in your y from your point, your m from here, your x from your point, solve for b. Okay, that works. I like it. Okay. Or maybe what you start in is point slope. Okay. Maybe you like point slope form better because it works no matter where you are. And the thing that I really like about it is you're designing an equation from the beginning that still has y and x in it. And you just rearrange stuff so you get it to look like this, right? Because point slope, y minus y1 equals m x minus x1, where this 3 and this 5, this is x1, y1, right? So x stays x and y stays y, which wasn't true about this first, but I had to put those numbers in somewhere, right? Point slope gives us a spot where we can hold on to the variables and just drop in the specific point for whatever we've got, right? Y minus 5 equals 2x minus 3. Okay. Y is still y, x is still x, and all I have to do is rearrange things, get rid of parentheses to make it look like it's in slope intercept. Okay. And so what should I do? Well, I'll distribute the 2x minus 6, and then I'll add 5 to both sides. So y equals 2x minus 1. Of course, it's the same answer, it's the same setup. But I just like starting with an equation and then just solving that one, moving stuff around, rearranging it, making it look the way I want, rather than creating an equation to solve and then having to write the answer separately. But it's almost the same amount of work, so totally up to you. But know for sure, slope-intercept form is the way these questions are going to look when we're done. Okay? Now that's the parallel version. Maybe we want to see the perpendicular one. Oh, I've been sharing this whole time. Sorry. Let me stop sharing my screen so we can see the big version. Sorry about that. Okay, so there's that setup. That's if it was parallel. We could use that same y equals m. We'd use that same m. The other option, they could ask us to do the perpendicular, right? They give us the same setup. They give us a line. They give us a point to go through, but they say be perpendicular to your given line. Okay. The nice part is that the line that they give us is already y equals mx plus b, so you don't have to move anything around with that. You just have to pick the correct slope. And so if the slope that was given to us is 2, we want the slope of the line perpendicular to that. Okay, the symbol for perpendicular is an upside down T, which makes perpendicular lines, nice right angles there. Okay, slopes that are perpendicular are opposite reciprocals, negative reciprocals. Change the sign. So if it starts positive, make it negative. If it starts negative, make it positive. And flip that fraction upside down. So this is 2, so 2 over 1. So we want to flip that upside down. We'll call it 1/2. That's the slope that I want to make sure that I use for this problem, perpendicular. Okay? And then just pick a style and solve it. I'm gonna stick with my point slope, but either one's fine. We should get to the same answer. But I'm gonna start with an equation and then just move stuff around so that I can solve it, make it look the way that I like. Okay. So y minus 5 equals negative 1/2 x minus 3. The only thing that should change is the slope. The rest of the setup should be exactly the same. I'll multiply that negative 1/2 in. So y minus 5 equals negative 1/2 x. Negative times a negative is positive, and half of 3. Okay, 3 over 2. 1.5, fine. But your multiple choice options, I think, for this question are, if they're fractions, they're fractions. They're not decimals, okay? Just kind of keep that in mind. And then it's going to slide that 5 over. Okay, so y equals negative 1/2 x plus 3/2 plus 5. Okay, so 3/2 plus 10/2, right? 10 over 2 is 5, so I'm just common denominator there. So 10 plus 3, 13. Okay. Just one of these. You don't have to do both, the parallel and the perpendicular. They're just going to have us pick one. Well, not pick one. They're going to tell us which one to do. Okay, you just want to be comfortable with both. Okay. And again, you could, of course, do it in slope-intercept from the beginning. You'd solve for b. That b you would solve for would be 13/2 if you did. There you go. There are a couple of practice ones in today's practice that I will uncover for you. If you've got that up, I will share my screen as well so you can see it. And then I will do those, okay? If you're feeling good, though, and you want to head out, you are good to go. If you want to see the work for those 2 practice problems that are on today's practice, and all of the practice from this week, Tuesday, Wednesday, and Thursday, those are all linked to an announcement on Canvas that I think is something like practice from this week or this week's practice or something like that. In case you want to go back to the, I don't know, 6, 7, 8, 9 different mini lessons that I've done this week. So stick around if you'd like. Either way, before you leave, make sure you take the survey.
Thank you. Happy birthday.
Yeah, you're welcome. Thank you, guys.
Bye, Rosie. Happy birthday.
5 and 6, thanks. I'll work through 5 and 6 if you want to stick around and see it. If you're feeling good, you are good to go. Have a great break, and I will see you on Monday, November 30th. Maybe the next time you go.
Happy birthday.
Thank you.
Happy birthday.
Thank you. Okay, I'm going to stop sharing so you can see this a little better. There we go. Okay, I'll hang out for another 5 minutes or so. So you can ask questions if you have any. You can look back at these, make sure you're doing them pretty well. That's it. We should be ready. We should be really, really, really ready for this. The review will cover everything that you need, and we'll be good to go. Hi, Alex.
Hi.
I'm just going to stick around for 5 and help them finish up, and then we can talk.
Okay.
Thank you, Mr. Rosengren.
You're welcome. Have a great break.
I made you a card. I don't know if you can see it, but
Hold on. Let me
here
see.
it is.
Hold on. Let me see. Oh, Grace. Thank you. Oh, I love it. Nice.
All right. Well, happy birthday and thank you.
All right. Thanks. See you, Grace.
Bye.
Bye. I have the best students in the world.
Happy birthday.
Thank you.
Have a good break.
Thanks, you too.
Bye. Thank you. Happy birthday.
Bye. Thank you. See ya.
Let me get my stuff out.